All right, so in the last example, I was able to give you an equation for a function, and you were able to use all of our information about points of discontinuity, holes, vertical asymptotes, even horizontal asymptotes, x and y intercepts, to be able to graph the function, right? Sketch a pretty accurate graph of the function with or without that calculator. So what if I asked you to go backwards? What if I gave you the picture of the graph with all of the characteristics graphed in the picture and asked you to give me the equation of the function, right? So look at example number 5 with me. Looking at this, looks like a rational function. Let's pick out some of the characteristics that we've been talking about. I notice on this graph, it looks like there's a hole. It looks like there's a hole at x equals what? -4. It also looks like there's a vertical asymptote in this graph. It looks like there's a vertical asymptote at x equals +4. What else do you notice about this graph? It's not explicitly given, like with the vertical asymptote, that dashed line, but doesn't it kind of look like there's a horizontal asymptote right here? It looks like there's a horizontal asymptote to me at about y equals +1. So those are 3 of the main kind of characteristics that we've been talking about. What about x and y intercepts? So maybe looking at the x and y intercepts will also help us graph it, just like it did in the previous example. So it looks like to me on this graph, the graph touches the x-axis at 5, 0. So x is 5 when y is 0, so there's an x-intercept at x equals 5. Where does it touch the y-axis? Well, it looks like to me it touches the y-axis, gosh, is that 1? Maybe a little bit above 1. So I'm going to say that there is a y-intercept at 0, 1-ish, right? And we'll just use these as close values at least to help us kind of come up with the function, right? All right, so now that we have these characteristics, now let's work to go backwards and make an equation that has all of these pieces in it. I'm going to first start with the hole. If I know that there is a hole at x equals -4, well, that must mean that there is a factor that can reduce on the numerator and the denominator of my rational function of x plus 4. Remember, it's always the opposite. It's whatever that factor is set equal to 0. So I can say that there's a factor in my numerator of x plus 4 and a factor in my denominator of x plus 4. That's going to cause that hole at x equals -4. The next thing I'm going to look for is a vertical asymptote. I know those vertical asymptotes are when the denominator equals 0, right? After evaluating the holes, and in simplified form, what factor is going to cause that denominator to equal 0? Well, if there's a vertical asymptote at x equals +4, then I know that there's a factor on the denominator of x minus 4. That's going to cause my vertical asymptote. All right, one of the other things that we talked about is that horizontal asymptote. Remember P's and Q's? It looks like on this one there was that horizontal asymptote at y equals 1. If there's a horizontal asymptote other than 0, then we know that P has to equal Q, right? The degree of the top has to equal the degree of the bottom to give us that horizontal asymptote at the coefficients divided. So I know that the degrees have to be equal and our coefficients divided have to equal 1. So if my denominator were to be FOILed out, I know that I would have a 1x squared as my leading term. And so I need to make sure that I have a 1x squared on the top so that my P is equal to Q and that my coefficients divided equal 1. So I know the top has to have another factor so that when I take this x and multiply it, I end up with an x squared. So it's going to be x plus or minus something possibly, right? There might possibly be another number there so that when I do FOIL it, the leading term is an x squared, but that everything else still matches my graph and it gets me those x and y intercepts that I still need, right? So let's talk a little bit and use those x and y intercepts to figure out what that last missing piece is, what this last missing value is here at the top. So I know that there was an x-intercept at about x equals 5, right? Maybe an estimate, but close to 5. So when x equals 5, the y value is 0. So going back to our function, if I know that x equals 5, the y value is 0. And on a fraction, if the fraction value, the y value equals 0. That means the numerator has to equal 0. And that happens when x equals 5, right? When x equals 5, the y value is 0. So I'm going to take the numerator of my fraction, set it equal to 0, and plug in x equals 5 because that's my x-intercept. I didn't use, you might have noticed that I didn't use x as a variable because I already have x's in my original equation, so I didn't want to get confused. So I literally just kept it a question mark. You can put it as any variable that you want. Just be careful using x's and y's because those typically are reserved for our graphs and the x and y axis, okay? But we're really looking for this missing piece, this missing value, this question mark. We know x equals 5 when y equals 0. If I simplify that first parenthesis, I get 9. And so I have a new equation that says 0 equals 9 times 5 plus whatever that value is. Can I divide both sides by 9? And I end up getting 0 equals 5 plus whatever that value is. If that were a variable, right, and I'm trying to solve for that variable, I need to get that question mark by itself. What is that question mark? What does that missing value equal? So I'm going to subtract 5 to both sides, and I end up getting that that missing value, that question mark, should be -5. Now, let's also double check and make sure that that makes sense with our y-intercept. What did we say our y-intercept was? We said that it looked like it was close to 1, maybe a little bit above 1. So when x is 0, y is -1-ish. So if I plugged in a -1 and I plugged in 0 for all of my x's in this equation, and I think that this missing value should be this -5, what ends up happening? So let's plug in all those pieces. If I plug in x equals 0, if I plug in my -5 for that missing value, because that's what I think it is, do we get a y value that's close to 1? Because it should be, right? So simplifying that top, I end up getting a 4 times -5. On the denominator, I get 4 times -4. So -20 divided by -6. Two negatives divided give me a +5/4, which is a little bit over 1, right? And isn't that what we kind of said? It looked like it was 1, maybe a little bit above 1. So our y-intercept is perfect. It makes sense in our graph. Our hole makes sense, our vertical asymptote makes sense, our horizontal asymptote works, and our x and y intercepts are all perfect. So plugging in all the pieces, we should have a factor on the top of x plus 4 and an x minus 5. On the denominator, we should have a factor of an x plus 4 and an x minus 4, making sure that we have all the characteristics in our function to match our graph. Now, you could leave your answer like that, but most of the time when you see a problem, it doesn't give it to you in factored form. It gives it to you all kind of foiled out in standard form. So maybe even a better, more foiled out version, more an original function version would be x squared minus x minus 20 over x squared minus 16. All right, I want you to pause the video. I want you to try the next one. It looks very similar to this one. Pick out all of your important characteristics and see if you can come up with the equation for the graph.